Hello everyone, this is Nilesh here once again. In the previous session, we talked about the C-sharp regions and we discussed about inheritance. We discussed some basics of inheritance, talked about access modifiers, talked about different types of inheritances. We talked about object slicing, upcasting, downcasting. We also talked about the method hiding and use of new keyword. We seen how the methods and other properties of the base class are inherited to the derived class. We also checked how we can see whether a particular object is of a given type or not. That was using is operator. And then we can do the downcasting to access the specific features. We also talked about as operator for doing the downcasting. And most importantly, we discuss about the virtual keyword where we are overriding the method in the derived class to provide the modified behavior for that particular function. And then the function is always called depending on type of object. That was nothing but the runtime polymorphism. We also had the short introduction of compile time polymorphism, that is function with the same name and different arguments. The compiler is deciding which function to be called, and that was function overloading, and we shown the example of constructor overloading. Now, this particular video, we are going to talk about virtual functions. We will talk about inheritance. We will have one big case study where we will try to understand how exactly the inheritance virtual function runtime polymorphism is to be used in the real applications. We will also discuss about the abstract keyword and we will talk about the sealed keyword as well. So let us get started one by one. Here we are going to implement one mini project kind of stuff, though it will not be a full implementation, but here our focus is to write some basic prototype code and understand the actual use case for inheritance, virtual function, method overriding, and so on and so forth. So here we will get started with writing one employee class. And then in our project, we will have different type of employees. Maybe we will have labor, we will have manager, we will have salesman, we will have clerk, and then we will have even multi-level hierarchy like manager types are sales manager and HR manager. And we will try to implement all these things one by one. So let us begin writing one employee class. Let us consider that employee will have some ID and salary. And then we will also write one calculate income kind of a method, which is just returning a salary. But later, we will write a labor class where every labor is an employee, but laborers are not paid with their regular salary. Rather, their salary is defined as per the number of hours they worked and the rate at which they work. So the salary should get kind of automatically computed every time their hours and rate are modified. Let us see how we can implement it in practice. We will create a new project and get started from there. Name this particular project as virtual, abstract, and sealed. Now, as I said, we will begin with writing class employee. And this class employee, we will have few basic functionality like employee ID and employee salary. we can continue implementing the constructor, parametric constructor, and so on and so forth. For sake of simplicity, I'm avoiding them right now. But I want to write the function for calculating the income. Let me tell you, as we will go ahead with the other type of employees like manager or salesman, their calculation formula for the income will be different. And since I know that my upcoming classes or the derived classes might need the different behavior of calculate income, being a programmer of the employee class, I should declare this function as virtual in the base class. So let me write a virtual double, let's say calculate income. Currently for employee, this income is as simple as returning a salary. Then we can go ahead and we can talk about implementing a labor. Now every labor is an employee, so we will use inheritance syntax. But I said that for label, we will have the hours and rate. So let me declare like hours, and we can also have, let's say, rate. But we will implement one property for hours and rate. So hours is ready. On the similar line, we can implement the rate. So hours and rate is implemented. But as I said that labor will not have any separate salary. Every time we modified the hours and rate, it should reflect into the salary. So we can go ahead and put it over here. This dot salary is equal to whatever hours are given into whatever rate is given. And this is exactly same. I will also do it whenever the rate is updated. Here we see that salary is already implemented as auto implemented public property. And that is the reason it is directly accessible over here using this keyword or using base keyword. If you want, you could have declared it as a protected data member, and then the protected field of the employee can be modified, can be accessed in the derived classes. For time being, I just kept it simple with the help of auto implemented properties. One more thing that you should note over here, since the income of the labor is just same as income of the employee, that is just returning salary, and that is the reason there is no point in overriding the method calculate income into the labor class. Now let us move on to our next requirement. You can see the next requirement is implementing one manager, and in this manager you will be getting some extra bonus. So your income calculation formula will differ. Now it will be salary plus bonus for all type of managers. We do not want to differ it for every different manager category like sales manager, HR manager, and so on and so forth. I'm saying that I want this particular calculate income to be common for all the type of managers. So let us first implement it, and then I'll tell you how we can do this. So we have class manager inherited from employee. As we seen, we want one bonus to be there. And then we will override the calculate income, where we will return salary plus bonus. That's great. But what we are saying, this particular formula should remain same for all derived classes. So further derived classes like sales manager or HR manager, I'm not willing to have any different implementation of these methods. And this can be guaranteed by using something called as a sealed keyword. Sealed means the method is a kind of a final method, and that method cannot be overridden in the derived classes. Great. Let us go ahead and talk about the next class. Let's say I want to make sales manager. Now sales manager is a manager. So what extra I can implement over here? If at all you need some additional data member, yes, you can add it over there. But otherwise, I need not to implement anything. And you also note that this particular calculate income method is marked as sealed over here. Since the method is sealed over here, you cannot override that method into the derived class. If you try to override, it will give me the compile time error saying that cannot override inherited member because it is sealed. So you can never override that method over here. If you want some other members, yes, you can implement it. And similar story, you can see it for HR manager. Again, I can say that HR manager is a manager. And then inside this, if you want some additional member, like number of people reporting to the HR manager or any other information, yes, you can add it. For time being, I just want to keep it simple and empty. Now, let us take a look at a new requirement. What if I want some special manager who can handle the sales as well as HR? So, all functionalities of this sales manager as well as HR manager, I'm expecting in my special manager. So, you might consider writing a class special manager inherited from sales manager and HR manager. However, if you recall from the previous session that multiple class inheritance is not supported in C#. If I'm trying to do this, it is going to be the compile time error saying that special manager cannot have multiple base classes. So this sort of implementation is not allowed. Multiple class inheritance is not permitted in C# and Java. Let us continue further. Let us look at another requirement for this mini project where I want to talk about a salesman is an employee and each salesman will have commission. So actual income of the salesman will be the salary plus commission. Let me check how we can implement it. So let me write salesman class inherited from my employee class. And in this, as I said, I want the special member, let's say commission. And then we will override the method where we will return the salary as well as commission. That's great. So our salesman class is also ready. And then we will continue further to talk about another type of class that is nothing but the clerk, where we are saying that clerk is an employee. But I want to write my clerk class in such a special way that no further classification of the clerk is expected. So I do not want in future any new class to be written like data entry clerk or like file handling clerk. Any kind of specialization of the clerk is not expected. So how we can implement that? Let me first make the class clerk over here, and this class is inherited from employee because clerk is an employee. Clerk doesn't have any kind of commission, and that's why its income calculation is same as employee. There is no need to override it. But as I said, I do not want anyone to write any class inherited from the clerk class, that can be done by making this particular class as a sealed class. If this particular class is a sealed class, what will happen? You can never write any class inherited from the clerk. So if in future you try to make something called as a data entry clerk inherited from the clerk, then what will happen? It will give me the error saying that this class cannot derive from a sealed type clerk. This is not allowed. This is not permitted at all. In the previous session, we talked about object slicing and also talked about upcasting. Let us see the practical use case of these upcasting and runtime polymorphism. Now, in a company, you will be having the different employees. Let us consider the set of employees in a company. Let us say that this is array of employees. And in this array of employees, I want to create number of employees one by one. Let us consider that the first employee is a labor and his employee ID is, let's say, 3. Then his rate is equal to maybe 100 and number of hours he worked is, let's say, 20 hours. That's it. And then we can continue with the another employee. Let us consider the new employee is then salesman. This salesman is having, let's say, ID is equal to 5 and his base salary is maybe 3,000 and he got commission of, let's say, 1,000. Good. Then we will continue on to having another manager. Now this manager is kind of a generic manager and this generic manager is having ID is equal to, let's say, 1, where his salary is equal to 6,000 and his bonus is, let's say, 2,000. You can also have some HR manager in the company and this HR manager is having a salary of 4,000 and possibly a bonus of, let's say, 1,000. We can also have one sales manager in the company. So purposefully I have declared employees of different types over here. Let's say ID is equal to 4 and then let's say salary is equal to 3,500 and let's say he is also having some bonus of, let's say, around 1,500. Finally, I would like to add one clerk here and this clerk is having ID is equal to something and let's say that the clerk salary is around 2,500. That's it. So this is how I have created the set of employees. Now, what if I want some functionality which is calculating the total expenses for all these employees? If at all I want to write this kind of functionality, ideally where this particular functionality is to be implemented, definitely this can be implemented into our main class, into the program class, and we can pass the array over there. But don't you think that this particular functionality is related to the all employees? If it is relevant to all employees, instead of writing it into the main, don't you think that this can be implemented by the same developer who has implemented the employee class? So let me go back and let us put this particular functionality of calculating total expenses into the employee class itself. So let me write it: public static double calculate total expenses. and we will pass the array of employees. Please note that the method is purposefully declared as a static method because we want to call this method directly without any specific object of an employee. We can directly call it as employee dot calculate total expenses. How do you calculate the total expenses? Yes, that should be quite easy. Let me declare one total variable, and the total variable is initially equal to 0. I can access each employee in the array and I will increment the total by actual income of each employee. Please note, I'm not calling salary over here. I'm calling employee.calculate income. And this calculate income is a virtual method. So method will be always called depending on type of object. And then this will eventually call the actual method in each and every employee derived class depending on the given object. And then I can return the total. Let me show you practically. Let us call this particular method employee dot calculate total expenses. I will pass this array of employee and then it will return me, let's say, total expenses over here. Let me print the total expenses as total expenses. Please note the sequence. The first one is labor, then salesman, then manager, then HR manager, sales manager, and clerk. Let's see how these methods are actually executed in a sequence by debugging it. Let me first make this project as startup project and begin debugging by saying F10. F10 and then I'm using F11. The first one is labor. So you will see that at this moment, whenever we are making call to the calculate income, since this employee is referring to a labor object, it will try to call the calculate income of the labor. However, in labor, we have not overridden this method. So eventually, it will call the method of the employee itself, which you can see it from here. Let us continue further. Again, we have the next employee. This next employee is salesman. Now calculate income method of salesman will be called. And then it will return salary plus commission, that is 4,000, which is added into our total. Then the next employee is going to be the manager. The calculate income method of manager will be called, which is returning salary plus bonus, that is 8,000 is returned from there. And then next employee, that is HR manager. Now the calculate income of the HR manager should be called. However, in HR manager, we have not overridden the method. So it will call the method from its base class, that is nothing but the manager class. You can take a look at. And then it will again return me the salary plus bonus, that is 5,000. Similar line, the next one we have sales manager. Even in sales manager, calculate income is not overridden. So it will again call the manager's calculate income, and then finally it will jump to the clerk. In clerk class, we have again not overridden the calculate income method. So it will call the calculate income from the employee itself, which is returning 2,500. And this way, we will have total of all these employee salaries, which is 26,500. You can print it over here. Let us take a look at the output. I hope you understood how runtime polymorphism works over here. Now that you got the idea about the virtual function, the multi-level inheritance, the actual runtime polymorphism, I want to focus on another angle with the same example. Now, let me remind you, in this particular example, we had written the several classes, starting from the employee class, and then the inherited classes are written like this. We have labor, manager, salesman, clerk inherited from the employees, and the sales manager and HR manager are inherited from the manager. But don't you think that if I ask you the question, can you have something called as only employee in your company? Technically, whoever is recruited in the company will be a labor or a salesman or a clerk or some manager. But there is nothing like only employee. So employee over here is one abstract entity. And if it is abstract entity, I really do not wish to create the object of the employee. How we can restrict that? I want to represent the employee as one abstract entity, as one conceptual entity. And that can be done by declaring the employee class as an abstract class. Moment a class is declared as abstract class, then you cannot create the object of the class. You try to create object of the class and it will give you error. Cannot create an instance of the abstract type. Please note that though you cannot create the object of the class, you can still create the array of the class, because you remember creating an array of the reference type is actually creating the array of references. So over here in the array of 6, we are creating 6 employee references. The actual object is not of the employee, but actual object is of labor or salesman or manager or clerk and so on and so forth. Then there is second aspect to the abstract keyword. Suppose I want to write one method in the class called as a do work method. Let's say I want to mention a method, something called as a do work. And I wish that all my derived class must have such kind of do work method. Now, since there is no one as like only employee, there is no work in general defined for any employee. And since there is no work defined only for the employee, there is nothing much I can write into the definition of this flow method over here. And then we can declare that flow method as abstract. Declaring a method as abstract method simply means that there is no implementation provided for this particular method in this class. But at the same time, the abstract in the base class make it compulsory that all derived classes must override this particular method. Let me tell you another angle for the abstract class. If a class contains any abstract method, then the class is kind of an incomplete class. And then there is no point of creating the object of such incomplete class. So whenever there is abstract method present in the class must be declared as abstract class. Let me revise two aspects behind abstract class. The number one aspect, if class contains at least once abstract method, the class is incomplete, and hence such class must be declared as abstract. This is mandatory. Then the second aspect, if a class represents conceptual entity and there is no real life object for that class, then the class should be declared as abstract. In this particular case, your class may contain abstract method or your class may not contain abstract method. These are two different perspectives towards writing a class as abstract class. In this particular case, yes, I do not want to create the object of the employee, so I can make the class as abstract. At the same time, if my class is having a do work method, which is abstract method, then I have to declare the class as abstract class. It is compulsory, it is mandatory. And the basic rule of the abstract class is that you can never create the object of the class. Now we talk about abstract method. The abstract method is not implemented in the base class. An abstract method must be overridden in the derived class. Now you see that this labor class is not inheriting, is not overriding this particular do work method. That is the reason then this particular class is giving me the error. Look at the error. Labor does not implement inherited abstract member do work. And if I do not wish to override that method over here, then it will force me to make the class also as abstract. And then again, I may not create the object of the labor as well. But in this particular case, I know what kind of work the labor does. And that is the reason I want to override the method do work over here. And inside this, let me print a very simple, the labor is doing maybe a physical work. On the similar line, I can continue on to the manager. Again, in manager, this particular method is not implemented, and that is the reason again it is giving me the error. You can again continue and override the method do work over here. And in this particular case, I can print a message. Let's say this is my manager, and I can call it as a general management work. That's great. Now, if you wish, then you may override this method into the sales manager and HR manager. If you wish, you may not implement this method at all over there. For time being, let me implement these methods here. Let's say I have sales manager and he is doing related to the sales management work. On the similar line, I want to override the method in HR manager, and in HR manager, he is doing the human resource management work. So this is HR manager and this is HR management work. There is a salesman, again the same story. You can again override it over here. Let me quickly show you something that you can do in the Visual Studio. If you are in Visual Studio, you can take the cursor over here, and if you take a cursor, it is showing you the potential fixes. In potential fixes, it can suggest you that implement the abstract method, and I can just click this and you find that the basic method template is ready for me. Inside that, I can write my logic saying that this is a salesman and salesman is expected to perform sales work. Finally, I have a clerk, and in clerk also I want to perform some clerical work. So let me go back and abstract method implemented with console.writeLine. The clerk is doing clerical work. Let us try to call all these methods from the main. Maybe I can continue the same main. Let's say for each employee in the array, let's say I want to print the method do work. Right now, we have total 6 objects, and that is the reason you should be able to see 6 times the method will be called in the same sequence: labor, salesman, manager, HR manager, sales manager, and clerk. You can check the output here: labor, salesman, manager, HR manager, sales manager, and clerk. So the overridden methods are called here one by one. I hope this gave you clarity regarding the concept of abstract class, abstract method. We also talked about seed class and seed method. Before we wind up, I just want to focus on one small concept. You might have noted that since employee is abstract class, you cannot create the object of the employee. Agree. But please note that in this particular case also, you can have constructor in the abstract class. Why you need constructor in abstract class? Because abstract class can still have the data members. The abstract class can have the other methods. If your abstract class has got data members, then these data members are to be initialized by the constructor of that particular class. So many times people are confused that if abstract class object cannot be created, what is the use of the constructor? Note that you can write the constructor over here, and that constructor will be called when the derived class object is created. In the previous session, we discussed that whenever we create the object of the derived class, first base class constructor is executed, and then the derived class constructor is executed. I hope you find this particular session very helpful, where we talked about the inheritance, runtime polymorphism, the virtual functions, the abstract class, abstract function, seed function, and seed class. See you for the next topic in the next video. Thank you very much.